Hey everyone, in this video we are going over transformation of graphs, specifically the secant graph. I have more in-depth videos on graphing trig. Go check that playlist, but in the meantime, crash course, here it is if you're studying for exams. So first thing we want to know, if we want to recall what the secant graph looks like, is you need to know the quadrantal angles and how secant behaves at each of the quadrantal angles, which means you need to know that secant is reciprocal of cosine and how cosine behaves. So what are my inputs or my angles of the quadrantal angles? We have 0, pi over 2, pi, 3 pi over 2, and 2 pi all the way around. Those are going to correspond to the parent function here, 0, pi over 2, pi, 3 pi over 2, 2 pi. As for the outputs, cosine is the reciprocal of secant, vice versa. Cosine equals 1 and negative 1 on the sides, 0 here. What is the reciprocal of 1? 1 for both the 0 and 2 pi. Reciprocal of negative 1 is negative 1. Reciprocal of 0 is undefined. When we have a piece of graph that's undefined, or a place in the graph, an x value, input value where the graph is undefined, that is where we would draw in an asymptote. So we will be drawing in a vertical asymptote in the two places that we just marked as undefined. That would be at pi over 2. Oh no. It's not acceptable. As I said in the last video, the number of syllables in the full word secant is equal to the number of asymptotes, and they are equally spaced, so it's going to be at the second and fourth location. Secant, 2 asymptotes. The type of symmetry in, I don't remember if I put it in the last one, secant and cosecant, the symmetry is odd. Cosine, the symmetry is even. Secant, the symmetry is also even symmetry. The only two trig functions that are even are cosine and secant. The other 4 are all odd. Okay, now in order to graph secant, you need to graph the underlying cosine. So cosine starts up there and goes to 0, goes to a min. Got to memorize it, got to know it, 0, and goes back up to a max, and then it would keep going down forever. From there, it's going to be reciprocal. Imagine you have scissors and you could cut it. So reciprocal, snip and flip. For the reciprocal, snip and flip. So snip right here, and then flip that little U shape to right there and right there. I'm actually going to go over it in a bit of a darker color. I don't know what this is, but just so it doesn't match the asymptotes. I think those were different markers, but they look alike. Maybe they weren't different. Maybe I picked up the same one. Did not mean to do that. Okay, so the solid little branch guys are the actual final graph. As for the domain and range, I talk about it in more detail in either the cosecant video I just put up or on the playlist for graphing trig. There's a specific video finding the domain and range of these. Go look, find it, it's there. Domain is all real numbers such that theta does not equal pi over 2 plus, distance between them is pi n, where n is an element in the set of integers. The range is from negative infinity until negative 1 with a bracket, union bracket 1 until infinity. I explained it more in other videos. Here, I'm not going to play with the color. I'm just going to change it. I'm not going to go crazy. K plus absolute value of A, K minus absolute value of A. H, and then you just do plus Q, plus Q, plus Q, plus Q. This is the last. The 4, sine, cosine, cosecant, and secant, have a period of 2 pi over b. The other 2, tangent and cotangent, have a period of pi over b. That is the main difference, and I use 9 tick marks when I graph tangent and cotangent, because, you know, this is my channel. I can do things how I want to do them. The domain is, again, all real numbers such that theta does not equal h plus q. That's going to be my first asymptote. So whatever that value is, plus period over 2 or 2q, same thing, okay? N, comma, where n is an element in the set of integers. And then the range, guys, I have no room for this, but negative infinity, comma, k minus absolute value a, bracket, union, bracket, k plus absolute value a, comma, infinity. Sorry, that looks horrible, but it's the same as it was for cosecant, and hopefully you can figure it out, all right? Because this isn't your first rodeo, right? We've been doing a lot of these. Now, just quickly point out, let's just grab two different colors to show the difference between a positive and a negative. Markers everywhere. Positive and a negative, so something that I can use that's sort of sharp and different. Let's do this color and this color, I don't know. Okay. So, positive secant, secant, two asymptotes, secant. Positive secant is going to correspond with positive cosine. That's positive secant. Ew, it's so ugly, I'm sorry. And I'm about to do negative secant. There you go. That's it, right? Beautiful. We love it. Now, apply. And if this is too fast for you, you got to go watch my more detailed videos. You can still put them in fast speed, but I have them. Go find the Graphing Trig playlist, or you start over at Sine and see if you could catch on. Here, I have 4 secants. What does that immediately tell me? I have a positive secant. Positive secant, so if I wanted to draw my graph, I have 2 asymptotes. Positive secant corresponds to a positive cosine wave. So I'm dotting in my positive cosine wave. Snip and flip. I'm drawing it before I even label one thing. There, drawn and done. Now I'm just going to go in and label stuff. So 9 is my k value. 4, I'm going to add and subtract. So I have 13. 9 minus 4 is 5. H, that's 3 pi. I might need a common denominator, so I'll leave it on the side. My b is 1/12, so period equals 2 pi over 1/12. Keep change flip, so it's 2 pi times 12 over 1. 24 pi is the period. So q is a fourth of that. I hope we could do that in our head, 6 pi. So that means I'm adding 6 pi, so I don't need any common denominator. 9 pi, 15 pi, 6 more, 21 pi, 6 more, 27 pi. There you go. Oh my gosh, lovely. Domain, all real numbers, such that theta does not equal 9 pi plus half of that, so 12 pi n, comma, n is an element in the set of integers. The set of integers is a z with an extra line. That is very ugly, you can't tell. Range, negative infinity until 5, bracket, union, bracket, picks up again at 13 up to infinity. Okay, the end. That was faster? Yeah, it was. Okay, good job, me. Thumbs up, thumbs down, comment, question, concern, interact with the video. I'm doing my best here, trying to do a crash course on everything. Everything already has videos. I have tons made on the playlist. Go find them. But, you know, if you are just trying to get the nitty gritty, came to the right place, get it all down, get it in your brain. Have a great day. Check the playlist, get the next one. It's going to be Tangent. Okay? Bye.